evaluate the series, the sum from n from 0 to infinity of 2 plus 3 to the n over 5 to the n. What we're going to do here is we're going to split this up as 2 over 5 to the n plus 3 over 5 to the n. And so this is going to be the sum from n from 0 to infinity of 2 divided by 5 to the n plus the sum from n from 0 to infinity of 3/5 to the n. So these are individually geometric series, and so we can find their values without too much trouble. So here C, the first term is going to be 2, and R, so this is going to be 2 times 1/5 to the n is going to be that term. So 2 divided by 1 minus 1/5 plus the base term here, the C here is going to be 1. When n is 0, this term is 1. And we can see that the common ratio is 3/5. We put that down here. So 2 divided by, that would be 4/5, plus 1 divided by, this would be 2/5. And when you add all of this together, crunch, 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 you end up with 5. So this is a nice little application of, similar to the things before, maybe a little bit extra twist. Now there's something that we should discuss here. How do we know we can break up this sum as 2 different chunks? Because sometimes we can't do something like that. Well here, theorem 1, linearity of infinite series, this will do so remember this will do the trick for us. So if the sum of a sub n and the sum of b sub n individually converge, then the sum of a sub n plus b sub n also converges. And we look at this line right here. And so we know that this sum converges to this value. We know this sum converges to this value. So here, this series here is the sum. The terms here are the sums of the 2 individual terms. So everything checks out. So that's why we can do this. Okay, let's end with a second pre-class problem. So please determine if this series converges, and if it does, please find its sum.